let's finish up this chapter and land the plane. Let's not crash it. Got an exam in here on Friday. And here's what to expect. The quiz plus chapter 3. Chapter 2 is going to be the main. Chapter 2 and chapter 3 are going to be the main bulk of this exam. Chapter 1, there'll be some significant figures rounding off, but probably 4 or 5 questions out of chapter 1. Most are coming out of chapter 2 with nomenclature, and chapter 3 with limiting reagents, stoichiometry, balancing chemical equations, and now percent yields. Okay, that's the bulk of this. If you have been following along and actually doing these worksheets and the homework and reading the chapters, listening and paying attention, and working the problems, you should be in good shape. If you aren't working the problems, you're going to be in bad shape. The only way you're going to learn these is not by watching me do it, but by doing it. Okay, that's why I give you these. We learn chemistry by doing chemistry. I will give you a practice exam. I'll probably put it on the line tomorrow, and it'll have answers to it. 2 ways to use a practice exam: the incorrect way and the correct way. The incorrect way is to use it as a study aid. Whatever's on that, I'm going to study. I'm going to use it to study. The correct way is to learn the material, take the test, and see how you're going to do. Put yourself in an hour situation like you're going to have in here, like it's the real deal, and then you can go back and say, oh, I need to work on that. Oh, I really need to look at that. Oh, I need to look at that. Okay? Because I guarantee you, 1 hour will not be enough for several people in here. So when you take an exam, especially one of my exams, there's the right way to take it, and there's the wrong way to take it. The wrong way to take it is to go from 1 to 2 to 2 to 3 to 3 to 4, 4 to 5, and 5 to 6. And you'll get to about question 43, it'll be time's up. And you'll have had 7 questions you haven't even looked at. The right way to do my exam is to go through, well, oh, this is a limiting reagent problem. It's worth 2 points. I'm going to circle and come back to it at the end. Because this is a nomenclature. Ammonium acetate, C. See what happened there? One's going to take you about 3 minutes, one's going to take you about 3 seconds. So you might have had 7 questions at the end of time that you didn't even look at. Okay? Circle the ones that you know are going to require some time, and then come back to those. Don't lose the easy ones, because they're all worth 2 points. Whether it's a limiting reagent or it's a nomenclature, they're both worth 2 points. Okay? Cool? Good? Yes?
Are we having a study session?
We don't know how to do a study session. We used to have an SI, but no one applied to the SI position this year, so we'll without an SI. Any other questions? Okay. All right, so let's finish it up. Let's start with the easy one that we know, just because it's easier to teach using a simple equation than it is to use a more complex equation. So let's take the one that we've been working on. If I take oxygen and hydrogen and I combust it, it's going to go to water. Okay. Very first thing I do when I see an equation like this is balance it. Okay? So let's say I balance it. If I balance it, I'm going to have 2 hydrogens, 1 oxygen, and 2 waters. Okay? So now I'm balanced. So let's say the question has 3 main questions that it's going to ask. If I start with 25 grams of hydrogen, and I reacted with 25 grams of oxygen, how many grams of water do I get out? Okay? Question number 1. Question number 1, how many grams of water? Okay? That, by the way, is going to be the theoretical yield. That's the most I can get. That assumes 100%. Oh, that makes sense. Question number 2. The reaction was run and 24.3 grams of water were generated. What was the yield? The percent yield of the reaction. Okay? Question number 3. How many grams of non-limiting reagent were left, assuming 100%. 100%. Okay? So if you're comfortable with those three questions, you're going to be comfortable with this chapter 3 of the stoichiometry. Okay? Because that's really the heart and soul of what we're doing here. Balancing chemical equations, working on theoretical yields are 100%, limiting reagents, percent yields, that's it. Okay? That's the bulk and that's the heart of chapter 3. So let's work it together. Let's work the problem. Now, roadmap time. I'm going from grams and grams to grams. Okay, so I'm going to have 3 equivalencies. I'm going to go from grams of A, moles of A, moles of A, moles of B, moles of B, grams of B. That's 3 equivalencies. But before I do that, I notice that I have 25 grams of hydrogen and 25 grams of oxygen. Okay, and I know that these are very different molecular weights, therefore one of these is limiting. So I've got to figure that out. So the very first thing I need to do is figure out which of these is the limiting. That tells me then how much theoretical water I can produce in the reaction. Stop me at any point, because again, I'm only going to lecture for about 10 minutes, and then we're working a worksheet very similar to this. Okay, so the very first thing I want to do is figure out how many moles of hydrogen I have and how many moles of oxygen I have. So I'm going to go from grams of A to moles of A in my roadmap. I'm only going to have one equivalency. So I'm going to have grams of hydrogen to moles of hydrogen, meaning grams of hydrogen, mole of hydrogen. Okay? I know that 1 mole of H2 diatomic molecule is 2 times the periodic table, which is 2 times 1.008, which is 2 point, this is where I messed up on Monday, 2.016 grams of hydrogen. That is by definition 1 mole. I also know that that's 6.022 times 10 to the 23 molecules of hydrogen because of Avogadro's number if I need that. All right. I also know it's 2 times Avogadro's number of atoms of hydrogen because every molecule of hydrogen has 2 hydrogens. There's a lot of information I know automatically from this. All right. So when I do this, I take a calculator. If I finally go to, just can't see it. So 25 divided by 2.016, and that gives me 12.4 moles of hydrogen. Okay? Likewise, 25 grams of oxygen, moles of B, or excuse me, grams of B to moles of B, 1 equivalency. Grams of oxygen, moles of oxygen. 1 mole of oxygen, because there are 2 oxygen atoms, equals 32.0 grams off the periodic table. So I take 25, I divide it by 32, and it equals 0.781 moles of oxygen. Now, this is a massive difference here. So stay with me, because this is where I lost some people I know on Monday. You're still trying to figure this out. I need a 2-to-1 ratio. Okay? 2 to 1. I have basically a 12 to 0.8. I only need a 2 to 1. I'm 12 to 0.8. So which one of these do I have a lot of? Which one's excess? A lot of that. A lot more than that I need. I only need 2 and I have 12. Okay? Down here I have 0.78, so I really only need 2 times this of hydrogen. So if you want to do that. It's the way you're going to do the more complex ones. Multiply that by 2, and notice, I need 1.56 moles of hydrogen. Okay? That's how much hydrogen I need, right? Because it's a 1 to 2, or a 2 to 1. I have 12.4. Oh, that's kind of cool to do that, because guess what? That's how I'm going to answer 3. Question 3 is the difference between those 2. Make sense? That's how much is left over. Of the 12.4, I'm only going to use 1.56 because it's a 2 to 1. Let me say that again. Of the 12.4 that I have, I'm only going to use 1.56 because it's 1 to 2. So that minus that gives me what's left over of hydrogen. Does that make sense? Okay. Since I know that one's limiting, I could plug it back in and do it all over again, but I'm just going to go and pick it up here at the moles. I'm going to go from moles of A now to grams of B. So I have two equivalencies left. Does that make sense? So on my roadmap, if my roadmap is grams of A, mole of A, mole of A, moles of B, grams of B, notice this step right here are these steps. Okay? So what this answer is this. So I can go take that and just do two equivalencies off that number. Okay, so now if I go to the mole ratio between oxygen and water and the molecular weight of water, I get grams of water. So I'm going to take this number now and I'm going to run it through two equivalencies. Okay? I set it up the same way I've been setting up all my dimensional analyses. Moles of oxygen down here, moles of water here, mole of water here, grams of water here. Well, tracking so far. Okay? That is going to give me, just like this gave me moles of hydrogen, which is what I wanted, this now is going to give me grams of water, which is what the question's asking for. Questions? So now it's just a matter of plugging it in. I know my ratio is a 2 to 1. Okay. I did see some people in lab yesterday at this stage of their calculations putting a 2 in here. 2 does not belong there. 1 mole of hydrogen weighs 2.0162. If you do put a 2 there, then this needs to be 4.32, just 2 of those. Okay, you can do it. It's just 1 mole by definition. Remember, this is an equal. 1 mole equals 2.016 grams. Okay? All right, so over here then, I know 1 mole of water is going to be 15.99 plus 2.016. So if we want to be technical, it's 18.02 grams of water, grams per 1 mole. So now if I take 0.781, and by the way, this isn't part of the calculation, okay? So I'm gonna move this over here. I don't want you to, in your notes, have that as part, that's not part of that equation. That's different, okay? So 0.781 times 2 times 18.02 equals, oh, that's pretty cool, 28.1 grams of water. There's your answer, okay? So the most I can get, if I had a perfect reaction, we call it quantitative is the word we use in chemistry. If I had a quantitative yield, meaning everything that I reacted over here went to product, I would generate 28.1 grams of water. But when I actually did the reaction in the lab, so my answer here, how many grams? 28.1 grams of water. But when I actually did the reaction in the lab, I got 25.3 grams. I didn't get 28.1, so I got less than 100%. How much less? Well, this is where you take actual over theoretical times 100, and that gives you your percent yield. And lo and behold, I got a 90.0% yield. It's kind of cool. I always tell my students when they're doing research with me, anything above 90, golden. Okay? That works. Okay, so 90.0% yield. Okay? Chunking right along. Last one, yes?
So when it what was the yield, you just assume that it's asking for like that kind of formula?
Yeah, yeah. percent yield is always going to be actual over experimental. Now, here's something that's tricky. Stay with me on this. In lab, especially in organic chemistry, sometimes I'll have a student do a reaction, something like this is an organic reaction, this is an inorganic reaction. But say we did this, and I'll have the student actually on the balance, they would end up with 31.4. For various reasons. They didn't weigh the vial correctly. There's still water or moisture in it. There's an impurity in it. Something went wrong in the reaction. And it actually weighs more than they should. So what is the theoretical, or what is the actual experimental yield? Well, it's going to be higher than 100%. So sometimes you'll have 104%, even if you can't, it just means something went wrong in either the calculation or the experiment itself. So if a question does ask you, make sure you know which one goes on top and which one goes on the bottom, because sometimes those questions are worded that way on purpose to actually throw you off and have it more than 100%. Are we tracking on that? So if you have more than your theoretical, it's got to be over 100%. Okay? And I have seen on standardized exams that question specifically geared that way to see, because most students say, oh, I put the smaller one on top and put the bigger one on the bottom. No. You put actual on top, theoretical on the bottom. Most of the time it's going to be less than 100, sometimes it may not. Okay? Last part of the question, how many grams of the non-limiting reactant did I have left over? Well, again, I required 0.781. 2 of those is 1.56. Therefore, this minus this is going to give me the hydrogen that's still floating around out here in the flask. So the way I'm going to do this is I'm going to go 12.4 moles of hydrogen minus 1.56 moles of hydrogen. When I do that, notice what I get. What is it? 10.8?
Yeah.
Okay. Now notice where I'm at. Where am I on the roadmap? Where am I on the roadmap? Yeah, either one. Moles of A. Okay? I'm right here. How do I get back to grams of A? Because that's what the question asks. Well, I have to go through the formula weight. So how am I going to do that? Well, I'm going to take 10.8 moles, put it through the roadmap, moles of hydrogen, grams of hydrogen. I just went the other way. Remember, the equivalency can flip either way. What drives it is what I start with. So in that case, 1 mole of hydrogen, I already know because I have that information right here, 2.016. So when I take 18 or 10.8 times 2.016 equals 21.8 grams of hydrogen in excess. Kind of cool. Yeah? You got it. Exactly, Hunter. So here's the cool thing. You can take this number plus, which number? It should be, yeah. So this is, we're going to use all 25. It's, where'd it go? It's going to be bottom right. Is it down here? So yeah, basically the grams that I used and the grams that are left over are going to equal the grams I started with. Yeah, which is kind of cool. It's a way you can check to see if the problem's correct. What do you think? Now, watching me do it, it might make sense. It's when you start to read it and fill it out and do it yourself is when where we need to get. Okay? Okay, there's no questions. We have a half hour. Let's work just like in The Martian. Let's work the problem. Work the problem. What's the problem? Work enough problems, you get to come home. It's kind of a cheesy line in that movie, but it also seems really good. basically. Why did you ask me that? What else? Questions? Oh, that's like, oh, you not, I'm sorry. Oh, just next week. Yeah.
Okay. So just trying to.
Yeah, for rain spot. Yeah, very good. That's fine. Oh, 274. That's cool.
You get one, two, then three, when you multiply everything by two, then it's almost like. You see how this is two, so this one has to be two. But then the oxygen is off. So they have to be on this side, so you have to multiply everything by two. So what I started with is one. This is take this. The problem is this one, this is the question is 20 grams. Is to do math.
Don't have to escape. So when you do that, that's a you problem.
No, but I need to know the.
Yeah, it's set up, it's the same as setting it up this way. Full equation. But it needs to be freezing it. Okay, and that's because you start, if you start at 3, you have cancels here, so that's 6, that's 3. This has to be 3, and that's why I wouldn't stop here, I would run all the way here. Not, yeah, do the whole thing with all 3 bullets.